Hi to everyone. We are doing maths, and this is introduction to calculus. So, there are four things which we need to consider in calculus: function, limits, derivative, integration. Function is the relationship between two quantities, substance, variable within certain parameter. Certain parameter means like the domain and range of the function f. And in the last video, I did explain about y is equal to f of x. Y is the function of x. F is the function doing things. In which I explain like y is equal to dependent variable, x is equal to independent variable. And the best example is the profit. Profit in business. Uh, it's dependent. We can take profit. Profit is a dependent variable, and the business, any item or services that we are providing, we can take that as a independent variable. So profit maybe goes ups and down, but our services remain the same. The product. So this is called function. We do it in mathematics. Is the rate of change. So function have domain, and if you are asked what is domain, so domain is the x-axis. Any point in the on the graph is x-axis is called domain, and the range is the y-axis, which is in the graph. Limit. Limit, and first thing in the limit is interval. So what is limit? Set of all real number exists between 2 points on a real number line, and real number line is this one. So and distance can never be negative, and we represent the absolute value like x absolute, y absolute. So and always if you come across with this one, so it has two values. The first one is x is less than equal to 0. Sorry, x is greater than equal to 0. This is the first condition, that if the x is greater than equal to 0, it starts from this side. And the second condition is x is less than 0, is not equal to 0, because 0 is a real number. All are real number, but it's not negative. So the it starts from negative -1. X is less than 0, -1. So in the limits, we use an equality sign: less than, greater than, less than equal to, and greater than equal to. So if you come across sometime, if I can say you like -6 is less than x, and x is less than 4 on real number line. So here I can write down this is 4. So here is from -6, but -6 and -4 is not included. This is parenthesis, a small bracket. This is the first condition we represent. The second one, usually in mathematics, but you it's not like, uh, but some we use it, but you can use only this one. 6 is not included. You're gonna start from -5. -5, -4, -3, -1, -2, -1, 0, 1, 2, 3. You're not gonna include. So this is your limit. It's a limit interval. And if I can write down like sometime, uh, the same number minus 6 is less than equal to x, x is less than equal 4. So with this condition, we use the square bracket. Are these two minus 6 minus 4? So here I can start from minus 6 minus 5 minus 4 minus 3 minus 2 minus 1 0 1 2 3 4. So in this minus 6 is less than equal to x, x is less than equal to 4, so we can include this one. Representation, if you want to do, is in this square bracket here, large bracket usually use. So what are the other things in the limits? So the first condition which I want to share with you, let's say c is less than x, x is less than d. So in this case, C and D is called open interval. Open interval in limit. Because C and D is not included. C and D not included. Whatever number is not included. Number two, C is less than X and X is less than equal to D. So this is called C and D. It's called closed interval. Closed interval in limits. It's called closed interval in a limit. That's very important. We're gonna come across in derivative and integration. And there is another condition number 3. C is less than x, x is less than equal to d. So it's half open and half close. This interval is half open and half close. Number 4, c is less than equal to x, is less than equal to d. So half open and half close. Half open, half close. When c is less than equal to x, so the c is included, but the d is not included. When c is less than x, c is not included, but d is included. You're gonna close on d. So that's the important things about the limit. So the third one is we're gonna do some example on this, but let's go to the introduction to derivatives. So there are two conditions in derivative which you can come across. Um, we're gonna do this by the application of limits. So we have to keep in mind that in derivative, one is average rate of change. Average rate of change. We use this for average triangle, and yeah, this is the first one. Number second is the exact or instantaneous. Instantaneous it's instant. Instantaneous rate of change. So in some situation, like a car has a speed of 80 kilometer per hour, and Let's say like 80 kilometer per hour per some time, and per how much time, it's per 10 second. So you wanna divide 80 divided by 10. So 8 kilometer per second. So this is the average speed. This is the average speed. You can't count. But here is the another thing that in mathematics, average rate of change we represent with the slope of secant line. Secant line. And for this, if you know, if you want to understand, you need two variable. So what we do with two variable. So let's this is I told you at the beginning you need a graph y dash x dash and x axis. So if there is a point A and the A is x y because x has some value and y has some value here. And if there is another point B, so and these are the 2 points, and this is the curve. So the secant line is in between the 2 points. This one. So there will be if this is x, so this is del x. If this is y, then this is del y. So the B has point x plus del x, y plus. So these are the 2 points. Mm, it's a secant line to the curve. This is called curve. So this is the rate of change because it's from A to B. So how you can find it? So it's another. I can give you detail when we are doing the derivatives, but actually we call it the secant line. Secant line change in y with respect to x, and it's the slope of the line. So we can find this change, and it's called we call it the average change of derivatives. The second one we can use a tangent line. Tangent line is the same slope dy by dx. But what we do, we apply limit if del x tend to 0. So when it's become 0, so it's called. So by this method, tangent line, we can calculate. We can calculate the exact or instantaneous rate of change at that point. So that's what we will use the tangent. So tangent is like this one. So it is y dash x and x dash. So tangent is the same point. Let's say it's A and B. So the curve like this, the change. So what is tangent? So tangent is any like this. So this is a slope you can, if the aeroplane going in the space, so you can find exact at exact point, certain point you can find the speed by calculus and by derivation. So this is called tangent line is called the slope of the tangent line. So another one other I want to share with you. If you know about the, we're gonna do this in when there will be certain question in derivation. There are certain function. So that's totally different. But this is par introduction, and that you can understand. And here is, this is tangent, and the secant is this. So what is secant line? If you remember that cos theta, cos theta is equal to in trigonometry base beta hypotenuse, while secant theta is it's the reverse reciprocal, so by base. So if in this example, this is the, if you take this is the base, and let's say this one, so then the base divided by half, so we calculate this ratio of the curve. So it's inside, tangent is outside. Another part, and we also know that tangent theta is equal to perpendicular in right angle triangle divided by base. So the same we are experiencing in the derivative. If this is the point and this is the point, so if this is A, this is B, so A is here, so this one. So the same we are experiencing the x and 2y, two values like this. So, but for you, it's enough to keep in mind that mm, average rate of change in y with respect to x. We represent this with secant line slope, and by the same slope, when we apply the limit, and it's actually it goes, I can give you an example about the secant line, where when we calculate the when we take 3 points between A and B and calculate the value of the slope, so it's actually 10 to 0, it's tends to 0. So that's where you can find the exact rate of change. So fourth is integration. So integration is the inverse of derivative. The derivative In derivative, we find the rate of change of quantity. Or any in motion or space or in these things, and integration is again we find out the quantity or the area under a curve. So this is integration. We gonna do now is mostly in the next lecture. I gonna do limit and function, but this is an introduction to the calculus. Thank you. Uh, if you are watching and enjoying the video, please subscribe to our video. Thank you. Have a nice day.